Dear students, today we will begin our practice on mathematics. My name is Dalman Karimov. The first topic is sets and operations on the sets. Firstly, let's give a definition to sets. What is set? We'll give a definition to set in naturally. So a set is a collection of things. The objects in a set are called the element of this set. For example, your group is also sets, and students in this group are elements of this set. A set is represented by listing its elements between set brackets. So the order in which this in figure brackets we will give, and the order in which the elements of a set are listed is unimportant. Example number 1, for example, represent the following sets by listing elements. A1. The set of states in the United States that border on the Pacific Ocean. So they are California, Oregon, Washington, Hawaii, and Alaska. Or the set of all counting numbers less than 6. What we have? Here we have 1, 2, 3, 4, 5. This is also set. And capital letters are used to name sets. For example, in this case, S, the name of our set, and an element will write by this symbol belongs to. So 5 belongs to S, and the statement 6 belongs to S means that 6 is not an element of S. Here we don't have 6. That's why it should be not belongs with stick. Like this. This is not belongs to our set. Now, a set with no elements is called the empty set or the null set. The symbols, this one and figure brackets, are used for the empty set. So if we let A be the set of all cats that fly, then A is the empty set because we don't have any cats that fly. That's why A is empty set, or A is in figure brackets empty, nothing. And we cannot write like this in figure brackets empty set. This is not correct. So in any discussions of set, there is some set that includes all the elements under consideration. This is set is called the universal set for this equation. For example, if the discussion is about President of the United States, then the set of all presidents of the United States is the universal set. For example, in example 1, there are 5 elements in the set in part A and 5 in part B. If the number of elements in the set is either 0 or a counting number, then the set is finite. So on the other hand, the set of natural numbers, for example, is an infinite set. Because there is no final number. We can list the element of the set of natural numbers as n is 1, 2, 3, 4, etc. This is the set of natural numbers. and it means this is infinite. Okay, for example, this set -2, -1, 0, 1, 2. The set is infinite because we have in the left side and in the right side elements, infinitely many elements. So the set of all natural numbers between 0 and 5, this is finite because we have just 1, 2, 3, 4. That's why it is finite. And the set of all irrational numbers, so it is infinite. The next definition: two sets are equal if they have exactly the same elements. For example, these two sets, 1, 2, 4, 7, 2, 4, 7, 1, they are equal because they have same elements. The order of element doesn't make a difference. And we have the next one, set. So if all elements of a set A are also elements of a new set B, then we say A is a subset of B. And we write it like in this symbol, A subset of B. Example number 3. Let A is 1, 2, 3, 4, B is 1, 4, and C is 1. Then we get B is subset of A, and C is also subset of A, and in at the same time, C is subset of B because we have just 1 here in C. In B, we have 1 and 4. The set of M, which is contained in element A and B, has 4 subsets. It is AB, it is A, it is B, and it is empty set, 0. The empty set is defined to be a subset of any set. And how many subsets does N, which we have 3 elements A, B, C, have? There is one subset with 3 elements. It is just A, B, C. And we have 3 subsets with 2 elements. It is A, B, A, C, and B, C. And 3 subsets with 1 element, A, B, and C. Just. So the answer is, and of course, empty set. And how many we have? 1, 2, 3, 4, 5, 6, 7, and 8. So, number of subsets. A set with n element has 2 to the power of n subsets. And we can prove for it is 3. You can take it. If it is 3, it will be 2 to the power of 3. It is 8. And we got these 8 subsets here. And to illustrate the relationship between sets, we use Venn diagrams. A rectangle represents the universal set Q, and the sets under discussion are represented by regions with the rectangles. For example, here in figure 1, uh, this figure shows that B, it is subset of A here, and they are from this universe set. Universe set we denoted by U. And for every set A, there is a set A prime, the complement of A, that contains all the elements of U that are not in A. For example, in this case, A prime, it is all of them. There is not in A, this one. Example number 4. Given U, set A, B, C, D, E, F, G, set A, set B, and set C, find complement of A, complement of B, and complement of C. So we have as universal set this U set containing with 7 elements. So A complement of A, it is, we have just A, B, C. So what we don't have, we don't have G, we don't have E, we don't have F and G. Similarly, in complementary of B, here we don't have B, C, and E. In complementary of C, we don't have A, B, C, F, G. They are complement sets respectively for A, B, and C. Now, what we have? We have a union of two sets. The union of two sets A and B, written as A union, this symbol union. B is the set of all elements of A together. With all elements of B. For the sets in example 4, A union B, here in example 4, A union B, it is what we have in A. We have A, B, C, and in B we have A, and we don't have in A, it's D, F, G. D, F, G. So this is union for A and B. Union of A and B. Okay. Now, in figure 3, the shaded region is the union of sets A and B. So this is union of two sets. And we have also intersection of these two sets. It will be later. So example number 5, after this we will consider intersection also. M is 2, 5, 7 and N is 1, 2, 3, 4, 5. Then M union N is 1, 2, 3, 4, 5, and 7. The intersection of two sets A and B written as A, this symbol. It means intersection. B is the set of all elements that belongs to both A and B. And the region will draw in this figure. It's shown. So A intersection B is shaded. So this one. This is A intersection B. In both of them, it should exist. This is A or B. I mean A intersection B. And one more example. For example, if A is these names, these 4 names, and B is these other 4 names, then A intersection B is Jose and Helen. because these two elements belong to both A and B. Example number 6. Suppose that P, Q, and R sets. So P intersection of Q is, let's consider P and Q separately. Intersection is 3 and 27. They have two elements, same elements. And the Q intersection R, it is 2, 10, and 28, correct? Because the both of them have these elements. And the P intersection with R, so it is, there is nothing because we don't have same elements here. That's why this is empty set. Sets like P and R, this example, that have no elements in common are called disjoint sets. Here, the graph of disjoint sets, they are not intersect. The intersection is empty point. The intersection is empty point. And the next operation, it is difference of two sets, A and B. And we write the difference between A and B with this symbol, A difference B. It is the set of all elements of A which are not in B. And the graph of this one is, this is universal set, let it is universal set. We have the set A and set B. This is A, this is B. And the difference between them, it is A difference B. This is the set of all elements of A which are not in B. This one. We cannot take this part because it included to B also. That's why the answer is only this part, this one. For example, A difference B and B. So in example number 4, the previous one, yes, it is here B and C, and AC, it is ABC. Example number 4. Here, yeah, this one. So A difference B, it is A difference B, it is B and C, correct? Because A, it is same element, and B with B difference C, it is A, F, and G. Example number 7. Let we have U set, A, B, and C sets. Find each of the following. So here, let's consider the first A1. A union B, it is all elements of A and B, 2, 5, 7, 10, 40, and 20. This is U set. And the B1, A intersection with B, same element. Do they have same elements? No, they don't have same element. That's why it is empty set. B union C. Here 2, 5, and 7. It is C set, correct. And B intersection with C. It is B intersection with C. It is same element here, just 5 and 7. This is B set. And implement complement of A. It is 5 and 7 because universe set minus A set it is. We can write A complementation. It is U minus A. Okay, next one B minus C. B minus C. Which elements we don't have in C? We don't have no elements. That's why it is empty set. It is empty set. Okay, now C intersection with B. C intersection with C sorry, minus C difference with B. It is just 2. Yeah, it is just 2. Which we don't have in B. It is 2. Okay. Next examples. If A is 1, 2, 3, B is 2, 3, 4, 5, then A union B. It is now 1, 2, 3, 4, 5. And intersection is just 2 and 3, the same elements. Next one. If A is the set of X belongs to real, the set of real numbers are, it is set of real numbers. Such that X greater than 1 and B it is such kind of X which is less than 2. Then find A union B. It is, we need to take the set which is greater than 1. Let's draw the line, real line. So for example, here we have 1 greater than 1. And in the next case, we have less than 2. If it is 2, less than 2. So where is the union of these two ones? All in all real line. That's why the union is R, the set of all real numbers. And intersection, where is intersection? Intersection is in the middle. 1, 2, bigger than 1, less than 2. So the intersection is here. That's why we have A intersection B. It is from 1 till 2. Okay, now let me clear open. We have product of two sets, A and B. So the product of A, B, this is pair of the functions. So pair of the sets, 1, 2, and if it is 2, 3, A, the product to B, it is 1, 2, 1, 3, 2, 2, and 2, 3. If we consider the inverse one, B, the product, Cartesian product to, we call it is Cartesian product also. The Cartesian product to A, it is now 2, 1, 2, 2. Firstly, the first element of B and first element of A. Then the first element of B and first element of A, it is 2, 2. Then the second element of B, we consider B product A. The second element of B and first element of A, it is 3, 1. And then the second element of B and second element of A, it is 3, 2. Okay, now example. Next example. So we have A, B, and C set. Find the following sets. And now let's do two of them here. For example, A intersection with B. It is what is same elements? It is 2 and 5. 2 and 5. The next one, for example, this one. A intersection with B intersection C. Firstly, we need to find B intersection with C, which is in brackets. So B intersection with C, let's rewrite A, 2, 3, 5 intersection, and now B intersection with C. So it is 2, just 2. And the intersection of these two sets is 2. Only one element, unique element. Now, next example. Okay, we have U set 1, 2, 3, and till 12, and let A is such kind of X from U, where X is prime number. So what we get here in A set, we get just prime numbers from U. What was the prime number? Which numbers? They have only two divisors, 1 and itself. They divide by itself. So here we have 2. The least prime number is 2. 2, 3, 5, 7, and 11. And now B set. B set is X is an even number. So we need to take all even numbers till 12. It is 2, 4, 6, 8, 10, and 12. And set C. C set is the X is divisible by 3. It is 3. It is 6. It is 9. And it is 12. So we have 3 sets, A, B, and C. And now find the following sets. For example, find number 4. A union B. It is A union B. It is 2, 3. We take all elements in A and in B. 2, 3. Here, 2, 3, 4, 5, 6, 7, 8, 10, 11, and 12. And intersection with C. C, it is the set of 3. The elements are 3, 6, 9, and 12. So the intersection of these two ones is 3, which we have in both of them. 3, then 6, we don't have 9, but we have 12. This is answer. 3, 6, and 12. So one more time, two elements, union of two elements is, if it is A, if it is B, in Venn diagram, by Venn diagram, it is this one. All of them. Okay, next one now. A intersection with C, it is intersection with C, it is 2, same elements 2, and just 2, don't have any same elements here. Yeah, because A was prime numbers, yeah, and B is even numbers. Sorry. We should consider A with C, not with B. A and C. So this is it is A and C. It is 3. A intersection with C. It is 3 and just 3 here we have. And now union B intersection with C. And here we have just 12. So the answer is 3 and 12. This is union of these two sets. And the next ones are we will do at home. Okay, now let A, B, and C be any finite sets. Then n, so n means the number of elements. And A union B, this is properties of these numbers. And A union B, it is n A plus n B and minus n A intersection with B. So n it is element of set, number of elements of set. For example, if you write here a set as 2, 5, and 7, for example, the NA is 3 because we have 3 elements. Similarly, we can find the any other B set. For example, define B set. It is, for example, 2, 9, and 11, for example. And let's write A and the number of n, A union B. So here we have let's check this property. Okay, so A union B, it is A union B, it is right here. A union B, it is 2, 2, 5, 7, 9, and 11. It is A union B. And number of element A union B, it is 1, 2, 3, 4, 5. It is 5. This is left side of our equality. Now let's take the right side. So NA it is 3, NB it is again 3, and A intersection with B. A intersection with B is just 2. So, and the number of elements of A intersection B, it is 1. So it is 6. 3 plus 3, it is 6. 6 minus 1, it is 5. 5 equals to 5. So we consider example to this property. The next one, if A intersection B it is empty set, then number of elements A union B is equal to number of elements A plus number of elements B. And here the next one, third one, the number of elements A union B union, this is C, union C, it is equal to n number of element A plus number of element B plus number of element C minus the combination of these three ones, number of elements A intersection B, number of elements A intersection with C, and number of elements B intersection with C, and plus the number of elements, the intersection of three of them. Okay, let's consider the next example. Example number 1. In a group of 60 people, 27 like cold drinks and 42 like hot drinks. And each person likes at least one of the two drinks. How many like both coffee and tea? If the problem is clear, let's show the solution of this problem. Okay, let A set of people who like cold drinks and B set of people who like hot drinks. So given the number of elements is 60, because in a group you have 60 people. And then number of A is 27 and number of B is 42. So there included the persons who like both of them, for example, cold drink and hot drinks. To find how many like both of them, we need to use the equation, this one, which we showed here. So n A intersection with B, it is n A plus n B minus n A union B from the first one. You can find n A intersection with B here. Move this one to the left side and this one to the right side. Okay, so we have n of A union B, it is 60. We have NA, it is 27, NB, it is 42. The sum of these ones are 69 minus 60, it is 9. So 9 people like both tea and coffee. Example number 2. In a competition, a school awarded medals in different categories. 36 medals in dance, 12 medals in dramatic, and 80 medals in music. If these medals went to a total of 45 persons and only 4 persons got medals in all three categories, how many received medals in exactly two of these categories? So if the example is clear, let's move to the solution. Let A set of persons who got medals in dance. Let B it is set of persons who got medals in dramatics, and C set of persons who got medals in music. We have three types of competitions. So given number of A it is 36, number of B it is 12, and number of C it is 18. And then the total number of persons, it is number of A, B, and C, it is 45. And who got medals in three categories? Number of persons is 4. So it means N, A intersection B intersection C. It is 4. So if we continue the discussion, the number of elements belonging to exactly two of three sets ABC is N A intersection B plus N B intersection with C and plus N A intersection with C minus 3 times this number A intersection B intersection C. Because we have these three ones. Look here, if we draw the picture, we have this one. For example, this is the A set, this is B set, and this is C set. Yeah. So, and we have this one. This is in the middle. It is the intersection of these three ones. It was 4. But when we compute this one, we have to subtract. This is 3 times. Belonging to exactly 2 of these ones. Because like this is yeah, and this one and this one we need to find without this in the middle, without this one in the middle, which is in the middle. This is, we don't need this one, we have this one. To find in blue. That's why each time we need to subtract this one. That's why we have 3 times this number. So now it is using the coefficients. We have n number of element of A, number of element of B plus number of element C minus n the union of A, B, and C, and minus 2n A intersection B intersection C. And if you put the values of these numbers, you get the answer 30. Okay, now we have set A, B, and C. Verify the following equalities. Let's consider the first A1. So A minus B union C. B union C, it is, let's write B union C. It is 2, 3, 4, 6, 8, 9, and 10. And A minus B union C, it is so what we have, it is 1, 2, A set is from 1 till 10, the set of numbers from 1 till 10. 1, which numbers we don't have here? 1, 5, 7. That's all. And now the right side, A minus B, it is A minus B is A minus B, it is here we have 1, 3, 5, 7, and 9. And the A minus C is so 1, 2, 4, 5, 7, 8, and 10. And now intersection of these two ones, intersection of A minus B, intersection with A minus C. So here we have same elements are 1, 5, and 7. So we verified our equation. 1, 5, 7 in the left side and 1, 5, 7 in the right side. And the second one with by the same way we can verify. These two ones we call also the Morgan's law. Okay, now the second one, how many elements do the following sets have? Here x belongs to the set of rational numbers, and 3n over n plus 2 we need to put instead of n from 1 till 50. And we need to find how many rational numbers when n changes between 1 and 50. And now comparing the sets A and B, number 4 here. So A set and B set we need to compare. To compare these two sets, we need to solve our inequality. The first one firstly, and it is so it's 2x minus 3 less than x minus 4, and here also the same one. So they are same, A and B, because we can cancel them. And the B one, so the set A is this set. So here again by the same way we can compare. try to do it yourself. You need to open these brackets and compare these two sets then. Okay, now so if you have this kind of sets, for example, the set is the solution of this inequality, and the second set is also solution of this inequality, and find intersection B or A union B. Firstly, we need to solve these inequalities, find the set of solutions, and then find what we need to find intersection or union or complementation. Here AC or A prime, they are same. This is complement of A and complement of B here. So in this example is also the same. So firstly find the solution of these inequalities, then the solution of these inequalities, and then find uh, union or intersection or complement or difference, etc. Okay, let's show one example here. For example, which one? Let's show the A1. So we will use the method of intervals. Here we have -2. So we can write it's like x minus 3, x plus 2, and change the third one, x minus 4. It is now less than 0. When we change, we will change the sign of inequality. So here we have -2, not included, 3, and 4. So plus, minus, plus, and minus. Because we have the odd powers here, only odd powers. And less than 0, it means x belongs to from minus infinity till -2, and from 3 till 4. This is first one, A set. And now B set. Here we need to factorize it. It is x minus 3, x minus 4, less than or equals 0. So here we have again method of intervals. 3, now it's included 3 and 4. So plus, minus, and plus. And now less than or equal, it means x belongs to 3 and 4. So union of these two ones is look here now. We have this set. It's -2. It is 3 and 4. It is this one and this one. In first case, in A, and in B we have 3 and 4. Yeah, so this ones. So intersection of firstly intersection of A and B, it is 3 from 3 till 4, and it's not included this one. X belongs to 3 and 4. This is A intersection of B, such kind of X from 3 till 4. And A union B, it is all of them. So here, A union B, it is such kind of X, 2 points, such that X less than or equal minus less than just less than minus 2, and X belongs to 3 and 4 included here, both of them, 3 and 4. This is A union B. Similarly, we can find A minus B or B minus A and other ones also. Complement of A here is this one is A, this one is B. The complement of A is this is in red, this is this one and this one. So A complement is X belongs to, now 2 and 3 is included because in A it's not included. Now in complement it's included from 2 till 3 and from 4 till plus infinity. Infinity is not included, of course. By this way, we can continue other examples also. Try to do the next ones home by yourself. The next time we will continue our topics. Thank you for your attention.